Hey again guys, and welcome back. You guys might remember that I love this thing. This is the fantastic Riden RD6018. This is a power supply which you can set the voltage and current pretty granularly. And the only downside really is that it has to be fed from a AC to DC power supply. So this is only a buck power supply. It can go up to 60 volts, 18 amps, but it cannot boost voltage, only buck. So only drop voltage down. I'm feeding this with a 25.4 volt power supply, so I can get just under 25 volts out of this unit. Banggood, however, have sent me something to make it even better. This here is actually the intended switching AC to DC power supply to go with this thing. And this thing is quite the beast. So let's see if this thing can turn an awesome power supply even awesomer. First things first, I have to notice, like, the packing is decent material. It's styrofoam. But this thing is a little banged up. Look at that. Look at that bend on here. And it looks like it's out of its... Whoops. I cut through the warranty sticker. Oh, look, and this thing's all flipped up. Oh, wow, yeah, this thing has been a little mangled in shipping. Now, this actually took, I have to say, Banggood is probably the quickest way to get stuff from China these days. But this thing took quite a while. And not just this, I've got a couple of things, even some stuff from AliExpress, for example, which just took forever. I don't know if it's a Canada Post deal or what, but yeah, shipping has not been kind recently. So, it did take a while to arrive, but I'm not sure if that's Banggood's problem or if it's just a normal postage thing. Okay. Oh yeah, and this guy too. Look at that. This is all bent to crap. There we go. Now I've noticed that these power supplies are really hard to find in appropriate wattage, because these buck regulators here, they are quite the power hogs. I'm going to switch to 110 volts. Is there any specs on this? Oh, here we go. So this one is 100 to 120 volt AC. That's what we have in North America, or 200 to 240 volts AC. You're actually pretty much the rest of the world. 50 to 60 hertz. That's good. And the output is 65 volts, 12.3 amps. So that's a lot of current. Still not enough to max out the RD6018. But it's going to get a lot closer than my 24 volt power supply could. And plus, it'll allow me to get voltages in the higher range. Because, again, I cannot do more than about 24 volts or so. I'm going to see if I can pop the cover back into alignment here. I just got to be careful because I see that this here is a heatsink. Nah, you know what? I think we went this far. Let's tear this thing apart. Here is a quick view inside. I was thinking that I was going to try to sort of do a little bit of figure out a little bit of the circuitry, but this seems actually quite complex, and I don't think I'd be quite able to give it any justice, you know, Big Clive style or whatever. If you look over here, there's two giant capacitors, 200 volt, 1000 microfarad, That's interesting. Is 200 volts. I guess that's for the DC side because this is a 65 volt. In fact, some people said they can adjust them up to 70 volts. So yeah, those are quite beefy. You got some really big ceramic resistors here. This is a 1K5, so 1500 ohm massive resistor, and then you've got a 51 ohm big ceramic resistor there. So we got these two. This looks like the mains transformer. Kind of makes sense. You can see that all the windings here are wrapped up in tape. So there's like the windings which are insulated plus the tape. Got this massive inductor, probably for noise suppression. You've got these output caps, 470 microfarads, 100 volts. These are the outputs here, and this is the mains here. You got a fuse here, but it's soldered to the board, so I don't know how good that is going to be. You do have a Class Y capacitor there. Pretty interesting stuff, and you've got 3 power devices. I can't really get in there to get a look. It's quite in there, but that's a very likely a power transistor, and these could be power diodes or maybe the switching transistors for the mains coil. Not 100% sure. You can maybe ask for me to take a look at this in the comments below, but this is quite complex, and I don't think I'm really the right person to be looking inside here. So it looks good in here. I have to say, like nothing is like flapping around too much. I could use a little bit more hot glue or Celastic or whatever. But the one thing that concerns me is this fan is actually fairly small. Like that looks like a 60 mil fan, maybe a 50 mil fan. Not very big, so I'm a little concerned of the amount of noise this is going to make, considering that you know, I'm going to use this in a sort of video producing environment. Now, I can always just print an adapter and put a 120 mil fan back here blowing across this way. That could be an option, but that will be for the future. So let me just show you guys how this cover comes on and off. See these little hooks here? 1 and 2. These hooks hook onto these little pieces, so you just kind of put it sort of further back than it needs to be, like so, and then slide it forward, and then make sure that this part is down flush, and then all you do is you put one screw over here, and one screw over here, and that's it. You are good to go. So now I just need to get an AC cable for this. Oh, and you got to put this cover back on. I'm not sure which way it's supposed to go. Sort of looks like it's backwards, like it goes this way, but that would be odd, wouldn't it? Yeah, I'm not sure about that. It seems to fit that way. Does it fit this way? Oh, it does. There we go. So you've got your neutral, live, ground, your negatives and your positives, and then you've got a little pot to adjust the voltage. So let's get these things hooked up. Got this crusty mains cable plugged in, and this here is the quad wires, 4 wires I used to run to the RD6018 at 24 volts from this power supply that I used to use. This is a 24 volt 15 amp dealie. So, you know, this one's nearly 3 times the output power. And because it's 60 volts at, 12 amps? 12 amps. So it's like, yeah, 2 point something times the output. This one here worked very well, but I was a little bit afraid with the 24 volts that I'd be pulling too much current through these wires, which I think are only 14 gauge. But now with 65 volts, it's going to be a little bit less. So that's going to be good. For the same power, it's going to be moving, fewer amps. So just going to hook this up. I've got these on, these are like these spade terminals, or these fork terminals that are made specifically for these kinds of things, or these, I should say these screw terminals work perfectly with these fork terminals. These I got locally, actually, from Princess Auto in Canada, kind of like the Canadian Harbor Freight. I'm going to plug this in. And I'm hoping that the cooling fan in here isn't particularly loud. Not going to hold my breath, but got the excellent Kaiwitz meter here. And the first thing I want to do is I want to check to make sure that the ground is connected onto this thing. It is. Perfect. Live, no. Neutral, no. And it's isolated. It seems isolated, at least, from the mains. Yep. So the DC and the mains are isolated. I do not have an isolation tester, so I wouldn't be able to tell you if the isolation is good enough. Also in the box, though, is this. This is green, brown, black. I think green is 5. So 5, 1 black, it would be 0. So 5, 1, 0. Then we've got brown, which is times 10. So 510, a 5K ohm resistor. And here there's a note. Maybe I'll have you guys read that. That's too small for me to tell. You can only connect the cables with a foundation electric and blah, blah, blah. Due to different power supply, production batches, internal material details different. Yep. There may be high frequency noise when the switching power supply is powered on, which can be improved by adding a load resistor shown as in the figure. So I'm going to add this load resistor in as recommended. There we go. We've got 0 volts. Let's plug this in. Contact. Oh boy, that was a big spark. 65 volts, right on the money. The read-in power supply is turned on with 6501. So that is pretty neat. That was a big surge of power inrush coming in. That's pretty crazy. I'm pretty surprised. I'm gonna check the AC volts and see if we have a offset or a ripple. Wow, the Kaiwitz is not detecting any ripple. I can hear a tiny bit of noise coming from this power supply. I feel like maybe it's fan noise? I'm not sure. Switch this back to DC. Yeah, our voltage is still bang on 65 volts. There we go. So I guess the next thing is to put this guy through its paces with this guy turned on, and yeah, we'll see if we can get, 60 volts through something. Well, just in preparation for this segment, I went and grabbed a bulb, and I think I'm going to try to put 65 volts through it. But this thing is making a ridiculous amount of switching noise. It's not fan noise. I checked. The fan's not spinning. But I don't know if you're going to be able to hear it on the mic. But it's making me feel kind of uneasy, the amount of switching noise. And it's probably because there's not enough load on it. Also, the load resistor, the 5K load resistor, is getting hot. It's dissipating nearly a watt. So 65 volts divided by 5K. That gives us 13 milliamps. 13 milliamps times 65, that's like 0.8 something like that. I did the math off camera. That is quite a bit of wattage. I mean, it is a 1 watt resistor, but it's getting pretty warm. I wouldn't be able to keep my finger on that. So yeah, a little weirded out by that. But then again, these massive power supplies, if you need the power, that's what you get. So let's set this V set. We'll go 60 volts all the way. I'm going to limit the current. I set 1 amp. I set 1 amp. Enter. Okay, and yeah, I'm a little sketched out about how this is going to go. It's probably going to do some. It's probably going to have a little bit of zappies. When you're talking about 65 volts, you are going to be probably getting arcs. Let's turn it on. Oh my God, the switching noise is gone. If the output is on, if it's pulling something, it's actually going to be much better. Here it goes. Oh, that got hot right away. Okay, just try to do this so you guys can see. Alright, here goes. There we go. Pulling 16 watts now through this AC bulb. And honestly, with the output of this thing on, even without the load on it, the switching noise is like gone. So I almost feel like this thing is good if you have a load on it. So I run the studio lighting here off of a power supply very much like this, but a 12 volt power supply. And I think if I were to implement this permanently, which I will because I like the headroom of having 65 volts, I probably will put buck converters down on the, loading it down so I can have 12 or 24 volt LED lights in here powered by this thing, and so the switching noise is gone. Because honestly, the switching noise, it felt like a pressure was relieved out of my head just now. So that is pretty cool. It is very cool being able to put 65 or 60 volts onto a device. I would love to fry a resistor with this, but you know what? No excuses. Let's do that. Okay, so 65 volts on the output, still 1 amp current limited. This is a 3 ohm resistor, but 2 in parallel, so 1.5 ohms. So turn this on, the voltage is going to go precipitously down. It's still going to get hot, and we'll see what the voltage that it's capped at will be. I just need to turn this on because the switching noise is insane. Okay, 1.51 volts, and now we can just go into the I set. We're going to move to the amps, and we're going to start cranking it up. 4 volts, 5, 6, 7. So we're at 10 amps, 15 volts, 200 watts, 220 watts, 300 watts. The fan has come on now. We're pumping 300 watts through this thing. 15. That's 350 watts now. 400 watts. Oh, I smell burning. Wow. Oh yeah, these things got toasty hot. We pulled 400 watts out of this thing. This thing didn't bulk at all. Oh yeah, that's that burning smell, but I'm pretty sure it's just these resistors because they are hot. Whew, that's stinky. Am I melting the wires on my power supply underneath? Nope, not yet. Alright, gonna unplug these. See if these connectors are hot. Nope, connectors are ice cold. This thing got hot. Are these supply wires hot? Nope, not at all. Cold. So that's what's nice, because we don't have to actually pull that much current through to get the wattage through here. Yeah, this is so hot. It's discolored this silicone. Oh yeah, silicone is very hot. Nice. Wasn't sure what was going to happen there. Now we know. So that's cool. Pull easy 400 watts out of this thing. This thing didn't even complain. Neither did this thing though. Last second update, I pulled the load resistor off, and now with the Riden power supply with the output off, there is no switching noise. If I turn the output on, you do get switching noise. However, if it has a load, the switching noise goes away. So basically, if you're only going to be turning this on when you have a load on the output, then I think the best thing to do is to omit this 5K load resistor. So this thing just dumped 400 watts and it's not even warm, like nothing even warmed up. It does use the sides as heat sinking, so you'd think it'd warm up, but it did not. So I'm just going to turn that on to turn off the switching frequency. That's the one big thing, that switching noise is absolutely horrid. So if I were to use this, I'm going to have to find somewhere sort of out of the way or on the other side of a freaking wall to put it. But you know what I think this would be ideal for? It would be to have one of these power supplies and 2 or 3 of these guys. The Riden RD6018 is by far the best power supply I've ever used. They do make a case that combines these two together. I don't think I want the case. I really want it to be able to tilt up like this so you guys can see what the voltage and current is. So I specifically want this thing to lay flat. But man, could I ever use, 2 or 3 more of these so we can, or 1 or 2 more of these, I should say, in order to sort of get a whole bunch of different voltages going for different things. This thing is awesome. This thing is just par for the course. If you want something that outputs this much current, 12 point whatever amps at 65 volts, you're going to have to put up with either some switching noise like this one does, which is fine until there's a load on it, which is not fine. I mean, it's fine when there's a load on it. Or you're going to have to shell out the big bucks. Because I have checked, and it is actually the same price on Banggood as anywhere else, but Banggood is the more reliable source, at least I find. So yeah, my recommendation would be, if you want to go up in the higher voltages with this Riden RD6018, you're going to want to buy one of these. And you're also going to want to have a constant load being pulled on it to get rid of the switching noise. And actually, my dream setup would be, 2 or 3 of these Riden RD6018 power supplies hooked up to one of these guys. You will not get the maximum output power on all 3 at once, but you can certainly power 3 different devices in a really precise way, and you'll have the grunt to do that. So if you want to get this thing or this thing is if you have a situation where you need that high voltage. This thing is, honestly, any electronics enthusiast should have a Riden RD6018 or something similar. These things are awesome. You can find them in the link in the description. And I'll also link to the full kit that comes with a case and everything, if you're one of the more typical use cases that probably are going to mount this on a bench somewhere. And I think having a case will quiet down the switching noise a little bit. But that's all for now. If you want to know more information about this thing, if you have questions, put them in the comments below. I will be testing this, doing a few different tasks, and I will try to answer your questions in a follow-up video. Thanks for watching.